right, welcome to the newest episode of Inside Tech Podcast. And today we are discussing about EVs and the energy sector in general, how the power grids handle and what kind of solutions there are. We have from Tether EV, Luis Medina today as a guest. Welcome, Luis.
Thank you so much for having me, Kari. It's a pleasure to be here.
All right, maybe Luis, you can a little bit tell who you are.
Yeah, so I'm the co-founder and CEO of Tether. I'm actually a renewable energy engineer. I come from the power sector, and I took a lot of interest in e-mobility and electric vehicles because of their applicability and relevance to the power grid in the coming years. So just to give you a little background about where I come from, I did my bachelor's of electrical engineering in the United States, even though I'm originally from Mexico. I worked at a power grid operator before jumping to General Electric, where I started as a gas turbine control systems engineer. I was there for a couple of months before I jumped to the General Electric solar division, where I designed hundreds of megawatts of solar installations for industrial and utility scale clients, before coming to Europe to do a double master's in renewable energy engineering. So it was during the master's that I started to really realize the rate at which electric vehicles were gonna explode in Europe. And the idea of this company started with a simple statistic, which is that a typical car is parked 95% of the time. So essentially, that's just a giant battery that happens to have wheels. And coming from the solar industry, I realized that's the missing piece of the puzzle in the green transition. So I'll be more than happy to talk about that as we go down the podcast.
Yeah, it's very interesting situation as there's a huge number of EVs coming, and the power grid also spikes and so on will be huge when the people come from work and start charging and so on. But yeah, Rika, you have been looking some forecasts on how this is actually, what it means in the numbers, the EV growth and the power demand.
Yeah, of course. It's important to figure out how EVs fit into our current power systems. More electric cars on the road would mean, of course, more strain on our power networks, leading to new challenges in managing how electricity is distributed. By 2030, it's projected that electric cars would require at least 500 terawatt hour of electricity globally. That's a significant jump from the 65 terawatt hour recorded in 2022 by the International Energy Agency, or the IEA as we know it. So how do we plan our distribution networks to handle this new significant load? And perhaps most importantly, how do we make sure that our electricity supply remains reliable with this higher usage? But I believe these questions are crucial, but we have here Tether EV to help us with the answers.
Yeah, I guess the solution is not to build more power plants to handle the spikes alone. So maybe, Luis, you can tell a little bit more what the Tether EV does.
We have a lot of electric vehicles coming online. They consume a lot of power. A typical car consumes around 2.5 to 5 times the power of a typical European household. So lots of power in an EV. There's going to be around 130 million of them in the next 10 years in Europe alone. And at the same time, we're transitioning towards renewable energy, which is fantastic. But you can't always control when the sun shines or when the wind blows. And that increasing consumption of power, coupled with the uncertainty in generation that comes from intermittent renewable energies, can be a challenge to the power grid operators. So what we at Tether said was, well, what if we could turn part of the problem into the solution? As I mentioned in the intro, right, an electric vehicle is parked 95% of the time, which means it's just a giant battery that happens to have wheels. So what if we could leverage those batteries to reinforce the power grid and complement the variability of renewable energy without needing to build new power plants to act as a backup? And that's what we do. So our software connects to electric vehicles that are parked all throughout a city. We coordinate when they charge or when they don't charge. And essentially, we turn them into a giant virtual battery or a giant buffer that allows the grid to operate in a more stable way.
Yeah, when I was looking at your website, I understood that currently it's more you are adjusting the demand side, but your future plan is to go to the vehicle to grid area also, that batteries could actually supply the power when needed to the grid. Is that right?
Yeah, absolutely. And there's a good reason for that. So most cars today cannot do bidirectional charging, or they can't charge and discharge. They can only charge and stop charging. But that you can already do a lot with that, right? So by coordinating cars, if you have 10,000 cars that are charging and you're able to pause that charging for a couple minutes at a time, that can add up to a huge difference for a power grid operator that's trying to maintain, the grid operational when there's an imbalance or something goes wrong, right? So that's what we're starting with. Essentially, flexibility of the demand of electric vehicles. What we do that's a little bit different from other companies is we're going after private users, so private EVs, whereas a lot of companies tend to focus on fleets. And that is a huge challenge because every single one of us has their own schedule. They have their own needs, right? So Rika and Kari, like you have, your life, you have things to do, and as do I, and we don't always sync up. But if we're able to tap into all the individual users and, using machine learning and optimization algorithms, we're able to sync up or coordinate when we all charge in conjunction to each other, then we can really have an impact on the grid without any impact to the user experience. And so that's what we're starting with.
Yeah. So your product basically works that EV owners will connect their vehicles with your application, and are you then you probably have to partner then with the national grid companies in the countries you operate, or how that works?
Yeah, exactly. But I will correct you there because we don't plan on making our own app. So we want to be a white label solution for partners. So essentially partnering up with charge point operators or e-mobility service providers, even vehicle OEMs, to give this functionality to existing applications that you may already be using. So in our dream scenario, you pull out your Audi app or Volvo app or whichever car you have or whichever charger you use, and you simply click on smart charging or flexible charging or what have you, and we're connected on the back end. We pull the data, we monitor how you're charging in conjunction to other people that are connected, and then we were able to manage the charge patterns that way. And to your point of the power grid operators, yes, of course, if we're gonna participate in the ancillary markets of a country, we have to get certified by the grid operator there.
So that's where you bring the biggest value to the OEMs of the chargers or vehicles, that you have the then certifications and so on to operate in the market to make financial benefit also of the flexibility. Exactly.
So that's why we're called Tether, right? We are the link between our partners and the grid. And essentially, what we tell them is, look, you're leaving money on the table. You have these assets, you have these cars, you have these chargers. We could make money every single time they charge, every single day, while helping your users and helping the grid and helping society. So it should be a win-win-win for everyone.
So to be clear, like your customers would be then basically the charge point operators, car manufacturers, and so on, right?
Exactly. Yeah.
Let's talk about policy a little bit. Especially in the EU, there are many policy and regulation regarding the EV sector, and more are being prepared in regard to the intersection between the energy and the electric vehicle sector. I read that in Spain, for example, regulations are increasingly supportive of the vehicles to grid technology right? They offer better pricing for energy return to the grid, simpler setup process, and potential financial incentive. But different EU countries have distinct regulatory. Other countries may have more restrictive regulations. So how do you get around it, since I assume you are planning to operate in multiple countries?
Yeah. I mean, certainly we plan on operating across the EU and even beyond. But you're completely right that the regulatory landscape is fragmented across Europe right now. There's some countries that have much more favorable regulations than others for this type of service. Spain is becoming more favorable for this. However, the rate of electric vehicle adoption in Spain is significantly lower than a country like Norway, for example. So in that case, what we're doing is we're starting in the Nordics. We think it's a fantastic market to really use electric vehicles for these services. The regulatory landscape in the Nordics is coordinated, so there's an agreement between the different transmission system operators like Svenska Kraftnät and others, Fingrid, right? So the regulation is very similar, and we see a high rate of electric vehicle adoption in the Nordics compared to the rest of the EU. For example, in Norway, around 70% of vehicle sales are electric today, and by 2025, that'll be 100%. We start there, and then we want to go down to the center of the EU, in countries such as Germany or France, where there's going to be a lot more electric vehicles, right? But they're still a little bit further behind in terms of adoption. So the Nordics are a perfect place to validate and test this solution and then adopt it on the EU scale.
So besides the kind of policies and regulations, which are of course different from country to country, what kind of other challenges you would say you are facing at the moment?
Well, I mean, I think certainly the regulatory question is a big one, because that determines some of the technical challenges that you have to be able to perform, right? So, for example, in Sweden, you only need 0.1 megawatts of power to be able to participate on the markets, whereas in Germany and France and other countries, you need 1 megawatt minimum, right? So that means the number of vehicles that you need to aggregate to be able to even start this service is very different in these countries. So that's one of the challenges, is making sure that the solution we come up with is scalable and able to adapt, or is adaptable to the different regulations across the EU. The good news is that when it comes to these balancing markets across Europe, they're unifying, and we now are seeing a pan-European balancing market known as FCR cooperation and Picasso, where you have multiple countries that have agreed upon the market structure and what the product should look like and what the technical requirements are. So that will make it much easier moving forward to expand.
And now let's talk about the competitive landscape of this industry that you are in. I'm really curious to know your perspective on the current state of the market. How do you perceive the competition and challenges within this space? And I guess, what is Tether EV current positioning within this competitive landscape?
Yeah, that's a great question. I mean, competition is ramping up, which is good news. I mean, a lot of people think of competition and they say, it's becoming crowded. But what it really signals to me is that there is a big market here, and that's why you're seeing more and more startups that are popping up across the world that are trying to tap into these kinds of services. Like I said, we're doing something a bit differently from a lot of startups that have come before, which is, a lot of people, they targeted electric vehicle fleets, and that makes a lot of sense. That's a low hanging fruit. Essentially, you have one owner or one operator of hundreds or thousands of vehicles, and they are able to control when they come, when they go. Think of FedEx or UPS or something. So that's easy, right? Because you have one central controller and you're able to leverage the flexibility of those vehicles from a centralized manner. What we're doing differently is we're trying to go after the private vehicles, right? What happens when you have thousands or millions of people, each with their own decisions, their own life, their own schedule? So that's a much bigger optimization and predictive challenge. So we're really spending the majority of our time developing a machine learning and optimization model that is able to capture the granularity of individuals and use that to provide flexibility for the grid. So I would say that's one of the differences between us and other startups that might be doing something similar.
Yeah, when I was taking you now after we talk, I understand like your approach, and then something I was familiar as a EV user, at least in Nordics, there's this Cridio. Are you familiar with that one? Yeah. They are doing something similar. I would say that at least in the in Finland, at least, it's very popular nowadays. If you use a lot of energy, you are using a spot pricing, the market pricing per hour. And yeah, I was also myself testing, but I'm doing manually my charging schedulings and so on, because the app was a little bit buggy when I tried it. But do you see that kind of, because they are also going after individual users, at least in the countries where the spot market is popular, you get quite huge savings in Finland because the electricity price during the day can vary a lot. Do you see them as a competitor?
So what they do, from what I understand, they look at the spot prices of electricity. They try to find when the prices are lowest and charge a vehicle during those times rather than during higher periods of prices. And that saves you money, right? And that requires you to have a variable electricity contract, which means that the amount of money that you pay for your electricity changes throughout the year depending on what the price is on the market, right? So certainly that's something that we do, right? We try to minimize the cost of charging. Something that we do differently, and I don't know if Grid.io is actually doing this, but we not only try to save you money, we try to make money on the balancing markets. So not the spot markets, but the balancing markets. And essentially what we say is we can change the moment to moment that your vehicle is charging or not charging according to what's happening on the grid in real time. And by standing by having that flexibility to stop or start charging your car, even though it wasn't scheduled to do so, and do it only for a few minutes, you're able to earn revenue from that. And so it's not just a matter of cost saving, it's a matter of revenue generation. I think that's where we're a little bit different. And I don't know if Grid.io does that. Maybe you can correct me if I'm wrong.
I also don't know because, like I said, I'm manually scheduling at the moment when I need to charge 1 or 2 times a week. So it's not so huge load for me because I don't drive that much after the pandemic anymore. But yeah,
so that's a great use case. Sorry for interrupting you.
Yeah.
So that's a great scenario you just pointed out, right? So you only charge once or twice a week. So you're doing it manually, which is I think what a lot of people do, and I think that's where smart charging of, hey, let's charge when it's lowest and you don't have to think about it, makes a lot of sense. But imagine now, Karri, that you plug in your car and you don't charge it, right? So all those other days that you're not charging the car, but if you're at home, you plug it in and you reserve the right to start charging for a few minutes at a time in case the grid needs that. You could be continuously earning money from that, every single day, even when you're not charging. And that's kind of what we're able to come in, right? So even when you're not actually charging the vehicle, as long as it's plugged in, as long as you have the opportunity to charge it when it's not charging or vice versa, you're able to generate revenue on the balancing markets. And I'll be more than happy to go into additional detail on that.
Yeah, okay, that's the interesting aspect also that you can kind of profit from not charging also. And one thing more, I started thinking that when you say that you're not doing your own app, which means that then you will not be relying on the car's manufacturer's APIs or anything, that it would be their own software which would handle the communication with you. So it probably also removes the issues I have faced with this kind of external apps who are using the API of my car software to control the charging.
Yeah,
Did I understand
exactly.
correctly?
Yeah, exactly. Yeah. And so we're on the back end, right? We're directly connected to their services or their servers or their back end, either with a direct connector or other methods. And the reason we're doing that is, one, I think people are sick and tired already of downloading a bunch of apps to charge their cars. So if you want to park around a city, or you want to, charge your vehicle, a lot of times people end up with 3, 4, 5 different colored apps that do the same thing, which is a pain. So we didn't want to be another one. And the second reason is, to be able to do what we want to do, you need very low latency, right? You need fast response times. And going through the APIs, like of these OEMs or other players, oftentimes can lead to additional latency. So that's why we partner directly with them to find a solution that allows us to be unintrusive to your experience, right? You don't know that we are, there's not like an additional app you have to download. It's just in the app you already use or the service you already use, while being able to perform the service fast enough.
I'm sold to the idea based on the easiness. Wondering when I can expect that there would be the cars manufactured in Europe, or like Volkswagen, Audi, or Tesla, that they would be enabling this kind of services in their software.
That depends a little bit on them as well. I think car OEMs are not known for their super fast speed, but we're already working with them. Actually, we have a proof of concept with Audi already in process, and we're speaking to multiple other OEMs as well. So fingers crossed, we'll have multiple partnerships locked in before the end of the year, and then it's just a matter of going through the testing and validation, and I'm sure that will take a little while, but we're already doing testing with real cars and real chargers already, so soon.
Yeah, but the good thing is to see that nowadays that the cars can actually update the software without going to the service quite often. So once kind of concept and testing is done, it's easy to enable, because as far as I understand, this doesn't require kind of hardware changes. It's just a software update then.
Yeah, exactly. I mean, and all we need is to be able to connect to the car and be able to pull some data, such as, is the vehicle parked? Is it connected to a charger? How long is it parked, etc. If we're able to do that, we can then pair that up with other data sets, such as the weather, or what the demand is on the grid, what the renewable energy production is. And we kind of put them all side by side and trade a model to kind of predict what the demand will be, what your usage will be. And if we're able to do that, then we're already able to kind of schedule and change the vehicle's behavior, right? So you're right, there's no hardware involved. Now, when it comes to vehicle to grid, there is a need for new hardware, right? Not all chargers can support charging and discharging, and not all vehicles can do charging and discharging. So some brands like Polestar or Volvo have said that all of their vehicles going forward are bidirectionally compatible, and as over-the-air software update will enable them to be able to discharge, even though they can't today. However, that's not the case for all cars, and so it varies brand to brand. So once we want to step into the vehicle to grid aspect, it will vary depending on the car and the charger.
Yes, my next question for you is probably about the trends. As someone that is following the industry very closely, what are you excited about right now? Like, is there any trends that you are following, or is there any emerging technology that you think is going to be the next big thing in the market?
In relation to e-mobility or the grid or both?
Or both, because like your business is more the intersection between e-mobility and the power sector. Yes.
Yeah, and I think actually what you just said is great. So I think what we're seeing right now is a historic moment, which is the transportation sector and the power sector have been completely different for centuries. And all of a sudden they're clashing, and one affects the other, and I think they're inseparable from now on. We won't be able to talk about one without talking about the other. So what am I excited about? Well, vehicle to grid is the big thing that's coming. It's still in its infancy, but I think once that starts to become commonplace, you're really going to unlock the potential of vehicles. Because, like I said, typical car is parked the vast majority of the time. So it's not just about what the vehicle can do when you're driving it. It's arguably even more important what a vehicle can do when you're not driving it. And I really think that we're going to start to see vehicles not as a thing that takes us from point A to point B, but rather as a mobile power plant. And when you think of your garage, you're going to think of your electrical room, your power plant room. That's going to allow you to take additional solar power from your rooftop and store it in your car and use it later. If there's a power outage, you can use your car as a mobile generator if you go camping or whatever, right? So actually the Ford F-150 Lightning, part of its selling point is, hey, you have this giant pickup truck that's a giant battery, and if you go to a construction site, you can power your equipment, without needing a generator or something like that. So I think vehicle to grid will radically transform the way we view cars, and it will radically transform the way that we interact with the power grid, because what that essentially means is we are no longer just consumers of power, right? We are now what's known as a prosumer. We produce and consume. We alternate between that. And if you have that at every household, all throughout a continent, you're able to have a decentralized, distributed power system that is resilient to single points of failure, right? So if you go to war, we have to talk about the war going in Ukraine. You can't have one power plant that is blown up and now an entire city is without power, because now you have single points all throughout a country, all throughout a city that are able to absorb and provide power, and now you have a resilient and hopefully green power system. So hopefully that answers your question.
Yeah, that is truly interesting that my car's battery could, even in a cold winter day, it could keep my house running for 3 days or something, I calculated.
Yeah, exactly. Yeah. Maybe you remember what happened in Texas a couple of maybe like a year ago or maybe 2 winters ago, where
with the storm.
Yeah, with the snow and there were thousands or millions of people without power, and it was freezing, and the water pipes burst and everything. That was because they didn't properly plan for the cold temperatures, and then they lost some power plants, and then the grid collapsed or was really close to collapsing. But now imagine that all those people had an electric car that's able to discharge in their garage, right? They would have been able to keep the power running. The grid probably wouldn't have collapsed in the first place. But even if it was, you, Karen, you, Rika, you could keep the power, like the heating on, the lights on. You could do that for 2, 3, 4 days, depending on the size of your house and the size of your car. So it's going to change. I mean, it's just going to change the way we interact with the transportation and power system.
About the vehicle to grid, there's like a few challenges. What I'm aware is one is what we have talked, like that there would be cars supporting it, and they are slowly coming more and more models which support that. then of course, like the most of use cases, I assume they would be probably at home when the cars are parked most. That the charger at home is also capable, because my charger at home is not capable to put the electricity to other direction from the car at the moment. And I think,
I mean, you like you said, you need both the car and the charger to be compatible. And there's like there are competing standards right now that are being rolled out. So maybe this is a good time to talk about AC versus DC charging, right? And there's two schools of thought on what the future is. One is DC charging all the way. Essentially, for those of you who don't know, essentially what DC charging means is that, when you plug in your car to charge it, there's a converter on board that changes the alternating current from, the plug to DC current for your battery. So it basically allows your car to charge. But that converter can only be so big, and so because it's on your car, right? So that's what's known as AC charging, when the car converts the power. DC charging is when the converter is not on your car, but actually on the charger itself. So when you plug in your car to the charger, the current and voltage that's being supplied to it is already DC. So it goes straight to your battery, and you're not limited by that converter. So here are the schools of thought. One is DC charging is the future. It will allow cars to charge much faster. It makes a lot more sense to have the charger off board, etc., etc. What that does is it means that the control of the charging is essentially being done off board the vehicle. So charging manufacturers love the idea of DC charging. On the other hand, you have people that say, no, it doesn't make any sense. DC charging is much more expensive. Most people don't need to charge that fast. And of course, they want to maintain the control of the charging on board the vehicle. So that is a big question mark. Personally, I don't want to weigh in which one I think is going to win. I think they both have their benefits. But the vast majority of chargers today are AC chargers, especially when it comes to private users. So it's a long way to see if we're going to change the DC or not.
Yeah, and the third issue, like what I've been reading about vehicle to grid, is that when more and more kind of the small virtual power plants appear, it has to be coordinated somehow, because what I've read, like even the solar panel production is causing sometimes challenges to the grid operators, because it's a small, slightly unpredictable when they sell excess electricity. They are not committed to any load or so. So I think you guys come in the picture there when it's a vehicle to grid, to make it more predictable also for the grid operators what they can get out of the vehicle.
Yeah, absolutely, exactly. I mean, so this is becoming a big challenge for the grid operators, because it's, traditionally you had a few players, the big power plants, and they all got together 24 hours before, and they said, hey, we're going to produce this much power. And everyone shook their hands and agreed, and everything was fine. Now you're having, thousands or millions of small power generators around the grid, and it wasn't really designed for that, 100 years ago. So a lot of the traditional methods that power grid operators employed to be able to predict consumption and generation and power flows, right? Which direction the electricity is flowing, they're being challenged. So it's a very, very, very interesting time to be a power grid operator, because there's a lot of challenges, but also a lot of potential opportunities. So that's where, exactly, vehicle to grid and what we're doing comes into play, because remember, what we're trying to do is coordinate all these individuals, not just for what they need and what the grid needs, but also what they're doing in conjunction to other people, right? So rather than everyone coming home from work, plugging in their car and charging it at the same time, if all you care about is having your vehicle charged before you leave to work the next day, then maybe we can stagger that and we can have people charging, at 9, maybe at 1 in the morning, maybe at 3 in the morning. And that can alleviate the stress on the grid while making sure that your needs are met. And you're probably going to pay less electricity, less money for that. So it should be win-win-win. And that's kind of where we come in.
All right, this is very interesting. And if there's any car manufacturers present that is listening to the podcast, as an EV user, I would love to see this kind of stuff working natively from my car in the future.
Exactly. And I think if there's any car manufacturer listening here, the key here is that there should be a benefit for all the parties involved, including the users, right? So there's a way here to create a service that benefits the grid while directly, engaging the user to use your services more. So for example, Karri, let's say that we have a partnership with Volkswagen or Audi or whoever. And you opt in to make your charging flexible, right? It could be that through them, you now get a 10% discount on your next servicing cycle for your vehicle, which you're going to have to do anyway. And so now you contributed to the grid, you get direct savings on something that you were going to have to do anyway, and the OEM gets increased engagement from you on their services, right? So everyone wins in some way, shape, or form. So that's one possible future where this could go. So
it has been a very interesting discussion today, and thank you for coming to visit us today, Luis.
Thank you so much for having me. It's been a pleasure.
A special offer for our listeners. We are giving you full access to statistics for 30 days by registering at statson.com with the code STATSON, spelled in uppercase STATZON. Thanks for listening to our podcast. Visit our website and get our Text 360 newsletters. If you enjoyed this podcast, subscribe, recommend the podcast to your colleagues, friends, and family, and follow us on social media.